do that. So you are going to want to write this down because there's a couple things in here that we have not done before that we have to take a look at. So we've got this problem with this airplane. An airplane is traveling at a speed of 500 miles an hour with a bearing of 330 degrees. We have not explored that yet. What does that mean, a bearing of 330? And a fixed altitude, negligible wind and velocity. It says, note that a bearing of 330 corresponds to a direction angle of 120. So that's like, what the heck does that mean? Okay. And then we've got the wind blowing as well in a direction of 45 degrees northeast. So we first have to learn how a compass works, or a little bit about a compass. So if we've got a compass, it looks something like that, right? We have our quadrants, north, east, south, and west. Okay, so you scouts will probably be able to tell me what's going on here. But when we do a bearing of 330, that is compass direction. Okay, we are used to working on the coordinate plane or a unit circle, right? So we think 330, and we're going to go, we're not going to do that. That would be bad. 330 degrees to us is this, isn't it? Where we start on the positive x-axis, not on a compass. A compass, we start due north. This is 0 degrees, and we go clockwise. So on a compass, 330 degrees is this. Okay, that is 330 degrees on a compass. Justin.
On the problem we're given, it doesn't say that what angle corresponds to.
On what do you mean on what problem?
On the same problem, it doesn't give you what angle the 334. It's like 332. And
well, you got to be able to figure it out. And I'm going to teach you how to do that right now. Okay. So this is a 330 degree angle on a compass, right? Well, from our x-axis, if it ends at the same place, what's our theta? Well, aren't we 30 degrees short of getting back to where we started? So is it fair to say that squeezed in here is 30 degrees? Plus another 90? Our theta is 120, isn't it? Back on our regular coordinate plane. So 330 of a bearing or on our compass is the equivalent of 120 on our coordinate plane. So we're flipping between the two. Had our compass direction, and then we got to go back and take a look at our coordinate plane and see where that ends up. So your 332 becomes 118.
And you just do 450 minus the bearing?
Probably. I don't think of it that way, but that's fine. All right. So we got our plane. Our airplane is really at 100. Our theta is 120, right? And the airplane encounters a wind blowing a velocity of 70 miles an hour. I might as well put the plane's, what was the plane's velocity? 500? Okay, so is it fair to say that this black vector is the vector of our plane, if you will? And we'll make the wind is blowing at a 45-degree angle, right? So our wind is kind of coming this way, isn't it? But I'm going to take that, I'm going to put it at the end of my vector here. So my wind, the vector of my wind is this red one, isn't it? Okay, so I've got this direction I'm flying, but the wind is pushing me, isn't it? So that means we're going to have essentially a third vector. Let's do that in blue. It's going to look like that. Well, the blue one is our vector of our plane plus the vector of the wind. Okay, because the wind is pushing our airplane in that direction, isn't it? To the northeast. Okay, so we got to be careful when we fly airplanes. If we got to go to Tampa, we just don't set the setting for Tampa. We have to account for the wind. If we don't, if we don't account for the wind and set that setting, we're going to end up in Hilton Head or Myrtle Beach or somewhere. Okay, which isn't a bad place to end up, but it's not where you wanted to go. Okay. So what are the resultant speed and direction of the airplane? So we got a lot of work to do to get there. We've already done a lot of work though, haven't we? We've learned about compass direction versus our direction. We've been able to, compensate for that. We've drawn a couple vectors here. So let's take a look at, what color is my plane? Black. So let's look at my plane vector. My vector of the plane has a scalar of 500, right? Because we're flying at 500 miles an hour. And then we have the cosine of 120, which is our theta, plus, well, we'll do this, 500 sine of 120. So we're going to work on this vector of the plane. Any questions where we got the 120 from? Okay. And the 500 is just our speed of our plane, right? At the moment. Well, the cosine of 120 from our unit circle. Well, let's do this. Let's take out the 500. The 120 from the unit circle, the cosine of 120, is that negative 1/2? And the sine of 120 is square root of 3/2. So our vector of our plane is that negative 250 comma 250 square root of 3. Right, multiply 500 by each, and that's the vector of our plane. This is essentially I and J here, which I didn't write down. Now we have to account for the wind. What color was the wind? Was it red? Okay. So the vector of our wind, well, wasn't our wind blowing at 45 miles an hour? No, 70 miles an hour. Thank you. Our wind was blowing at 70. And then we have the cosine of 45 because it was a northeast wind, right? And sine of 45. Well, the cosine of 45, isn't that just the square root of 2/2? And the sine of 45 is the square root of 2/2. 70 divided by 2 is that 35 square root of 2. And 35 square root of 2. So that's the component vector of the wind. You guys with me on that?
Yeah.
So 70 divided by 2 is how I got the 35. Right? So, and it's a good thing this is exactly And I think in the problem that you guys have for 106, they talk about a southwest wind, or the wind is from the southwest. So on our compass, if it's from the southwest, there's west, that's south, it's going to be right there, right? Isn't this a southwest wind from the southwest, which is the same as a northeast wind, 45 degrees. Does that make sense? It's like exactly from the southwest. All right. So we've got our two vectors, right? We got our vector of the plane, the black vector. We've got our vector of the wind, the red vector. Well, we want to find what the resultant vector is, or the plane plus the wind. So all that is taking our two vectors, our two x coordinates and our two y coordinates, and creating a third vector. So the vector of the plane plus the vector of the wind is equal to the sum of the x's and y's. I need to give myself more room, which is just negative 250 plus 35 square root of 2 and 250 square root of 3 plus 35 square root of 2. Which is kind of ugly, but I reached for my calculator and I put negative 250 plus 35 square root of 2 in, and I did my homework before class today, and I got that this was a negative 200.5, it might be 0.51, and this one was 482.51. So that is my vector, my combined vector. Okay. So far, so good. I haven't answered any of my questions yet. The resultant speed and direction of the airplane. I have found my resultant vector, but I haven't found its direction yet. I've got the vector, and I don't have the resultant speed yet. Speed is magnitude. So my speed, which is my magnitude, is, let me erase all that. You guys don't get to see any of that in my videos that I shoot because I edit all that stuff out. So my magnitude, isn't that simply just the square root, negative 200.5 squared plus 482.51 squared? And I put that in my calculator, and I get 522.51. So that's my ground speed. So the wind is pushing me a little bit, isn't it? It's making me go a little faster. I went from 500 to 522 with that 70-mile-an-hour crosswind. You guys with me on that? Okay, so that's good. Got that one. That's one thing done. The last thing is direction, which is slope, which in our case is tangent. And tangent of theta, doesn't that equal B over A? Sweetness. There's B. There's A. Remember that? So arctan of 482.51 all over negative 200.5. Plop that in our calculator. And it spits out, move my Diet Coke, negative 67.43. Oh, I know what I didn't talk about today. Take the absolute value of that. We get 67.43. Erase the crazy red line. Edit that out of the video later on. All right, so this is 67.43, but in the second quadrant. The 67.43 is this angle. That's the 67.43. Am I making any sense here? Okay. Which means my airplane is getting pushed this way. That's 67.43. So 180 minus 67.43 is 112.57 degrees. Da, 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 da. My blue vector theta after the wind pushes me is 112.57. It was 120, but because of that crosswind, it's pushing me off course to 112.57. Yep. Does that make sense? I love working with smart guys. So that makes that 112.57. Did I scroll down too far?
Yeah. Thank you.
So that's my theta. Now that's not my compass angle though, is it? Yeah, my compass angle is, Wheezy can do that. Is that subtract 450?
Yeah.
So, which would make sense there. So my compass angle is at 450 minus 112.57. Well, because it's essentially 5 quadrants is what he's doing. I would do, which is probably, I would do this. For my compass angle, I'd go 90, 180, 270. I'd do 270 plus 67.43. That would be my compass angle. Does that make any sense? I would just start here at north and figure it out. But I think we get the same answer, don't we? Is that 337.43? This is the compass angle. I don't think that WebAssign asked for that. That's a, or your book does. I think that's a Mr. Rice thing. Clear as mud? So quick summary, right? Find the component vector of the plane. Find the component vector of the wind, which might be, maybe that's easier said than done, I don't know. Okay. Add the two together. And then from the added one, from your third one, you find the magnitude and the direction. You find the distance formula and then do the tangent, all from the third vector that we find. Okay, so on the problem you have for problem 106 for this first part, you're gonna get the cosine of like 118, and it's not on the unit circle, so you have to use your calculator right away to find it. Right, Justin? So your speed times whatever your cosine of your angle and the sine of your angle, your x and your y. How do you find question 106? My understanding is when you go to WebAssign, there's a link and you can click on it. And there's a picture of it? Is that what it is? I just inserted the picture. Can't click on it. The other thing is you can go to your textbook and go to the exercises for 6.3. And there it is. By that be a series of questions. It would probably like find the vector of the plane, find the vector of the wind, find the combined vector, find the speed, find the direction. I'd probably walk you right through it. Okay. So it'd be one problem with like 5 sub questions directing you to the answer. Okay. I tried my best to color code this. Vector of the plane, vector of the wind, combined vector. God, that's a mess up there in the upper right-hand corner though. And stuff we hadn't seen before in terms of like compass starts at north and we're usually starting on the positive x-axis as opposed to the positive y-axis. So Sam, question?
No.
All right. All right, I will let you guys work on WebAssign or problem 106. I'll pass back the quizzes to you. Can